Greetings and welcome to Week 3, Unit 3, related to cognitive processes, apply and analyze. In the previous unit, we understood the nature of remember and understand cognitive processes of revised Bloom's taxonomy. And this unit expected outcome is to understand the cognitive processes, apply and analyze of revised Bloom's taxonomy. Apply, what it means, use procedures to perform exercises or solve problems. It is closely linked with the procedural knowledge, which we will explore in later units. The sub-process of this, one is execute, the other is implement. Execute means solving a task for which the right procedure is already known. Produces clear solution. Routinely carries out the procedure clearly indicated in the problem or the context. It is generally familiar context. That is, in a familiar context, like you solve a problem in the classroom, follow the procedure and arrive at the what you consider as the correct result. You may change some small aspects of the problem, but it is exactly similar to that. And then you can ask that question to the student to solve. The procedure is known, context is familiar. The student needs to only perform the various steps in solving correctly. That is the purpose of execute. Whereas implement is solving a problem that has features which have not been encountered in that form earlier. There is some change from what has been explained or shown in the classroom by the teacher, and if you change something, now the student will have to find out what procedure to apply, or is the procedure whatever that is familiar is valid or not. If he consider it is not valid, what is it that he needs to do to solve the problem? And that is implement. Obviously, implement is at a higher order than execute. So apply category, if you look at it, is a kind of a spectrum of activities. At one end, we have the narrow, highly structured execute. As we move to the other end, we may have to select a procedure to tackle a new situation. As we keep moving to the other end of implement, we may have to modify a procedure. Then we may have to devise a new procedure also based on our conceptual knowledge. The move becomes towards the create to the highest level. That is, when you have to devise a new procedure, obviously it is a create process. So the action verbs that we are going to use to represent execute implement are the same more or less. Determine, calculate, compute, estimate, solve, draw, modify, and similar terms that you can use. As you can see, the action verbs that we are going to use are the same for both execute and implement. So once again, to go into the details, execute means to carry out a procedure that has been learned or practiced in a routine situation. Execute subprocess under the apply cognitive level refers to carrying out a procedure or task in a familiar context where the method or steps are known or previously learned. It involves accurately performing a task based on instruction or prior practice. Some sample activities of execute. Perform the standard procedure to prepare a concrete mix of specified grade in a materials lab. Perform a tensile test using a universal testing machine and record the stress strain curve. Conduct a titration experiment to determine the pH of a solution using standard acid-base procedures. Conduct a time study on a simple task and record observations using a stopwatch and standard form. Execute a step-by-step debugging procedure in an IDE to identify and fix a syntax error in a program. Now coming to implement, the implement refers to using knowledge, methods, and procedures in unfamiliar or real-world contexts to solve problems or complete tasks. Unlike execute, which is about performing known steps in familiar situations, implement involves selecting and applying the appropriate techniques to a new practical situation. It requires decision making about which procedure to use, involves transferring knowledge to new and applied contexts, often part of an engineering design, troubleshooting, or optimization. These are the activities that an engineer is involved in. Reflects practical problem solving skills in professional scenarios. So implement is always two-step process. One is from the problem, he has to identify or decide which procedure to apply and then apply that procedure. Whereas in the case of execute, what procedure to be applied is already known and he has to merely apply the procedure. That is a one-step process. Sample activities of implement. Design a temperature monitoring system by selecting sensors and interfacing them with the microcontroller. What you need to note is the action verb that we have used, design. It appears to be part of create activity. Design is actually a create activity. But for want of another word, we use the word design here. Here there is some kind of there are several procedures already known. The only selection, the student has to select a procedure and implement it. If you are performing some activity to come to a conclusion or to produce a product or a unit, then we use the word design. But in design process, here as a part of implement, we are not creating any new procedure. But still we use the word design here. Okay, so you have to remember that when you look at many questions that in the class tests and examinations, they start with design something, but that is not a create activity. It is only a apply activity belonging to the implement. Other sample activities, write an encryption algorithm to secure user input in a real-time data communication program. Build a prototype of patient monitoring system that uses multiple biosensors and displays data in real time. So you can say build is actually you are creating a prototype, whereas you can also say design a prototype, which is a paper level design, a plan that you create to eventually make a patient monitoring system. But here we use the word build also strictly belongs to the create category. But when you are following a known procedure, build also belongs to apply category. Then we move to the next cognitive level, namely analyze. It involves breaking given material into its constituent parts and determining how the parts are related to one another and to an overall structure. Given material would mean a very detailed verbal description is given to you, and you have to identify different elements in that, and you have to make certain decisions. Okay, that is analysis process. It is useful to consider it as an extension of understand and as a prelude to evaluate and create. So before we actually do something, first you have to analyze and then move on to evaluate and create. The sub-processes related to analyze are differentiate, organize, and attribute. The differentiate, what it means, distinguishing relevant parts or important parts from unimportant parts of presented material. Different from comparing in that the larger context is used to determine relevance or importance. Okay. Let's take a relook at that. You are given some information put all together. In that you are identifying what you consider important and what you consider unimportant. But that importance is decided in a larger context rather than by itself. Okay, and that is where it belongs to the analysis rather than merely compare. Then organize, the sub-process rather concerned with building a systematic and coherent connections among pieces of presented information. So you identify different elements in what has been presented to you and identify how one is connected to the other, what is the hierarchy that is involved, and what influences what. All that you organize the material, and that is the organized sub-process. And attribute, determining a point of view or bias, values, or intent underlying presented material. This can be more easily understood in the context of, let's say, a newspaper article. When you read the article, most of the readers can identify what is the bias, whether he belongs to the Congress party or to the BJP. He'll say, no, this is BJP's view. That is the bias that is incorporated in that. That many readers seem to be very quickly come to a conclusion. So identifying the bias or point of view, or maybe there is some value. A value, you identify the value. For example, it is a Hindu view of doing something. This is a Muslim view of doing something. You see that kind of either value system or bias. So that is attribution. The action verbs related to that are discriminate, select, focus, distinguish. Organize, structure, integrate, find coherence, outline, parse. Attribute, deconstruct. These are the action verbs that can be used for these three sub-processes. Now let us start with this differentiate. The differentiate sub-process of the analyze cognitive level involves distinguishing relevant from irrelevant parts, identifying how parts are related to overall structure, or recognizing underlying assumptions and biases. This skill is crucial in engineering problem solving and critical thinking. Some activities, sample activities. Given stress strain diagrams of two materials, differentiate between elastic and plastic deformation regions, and explain their significance for material selection and design. Anyway, in the sample that is given, there are two parts to the question. One is, given the stress strain diagrams, you are differentiating between elastic and plastic deformation regions. And the second part of the question belongs to understand category, where you are required to explain their significance for material selection and design. So if you want, you can make it two questions. A is the first one, second is the explain, or you can integrate into a single question. But here you should realize there are two parts in the question. Another example, review a structural plan and differentiate between load-bearing and non-load-bearing elements in a multi-story building design. Given a code snippet implementing a sorting algorithm, differentiate between the core logic and auxiliary operations, namely the input-output, memory allocation, and so on. Okay. So these are the examples of differentiate. Then come the next sub-process, organize. The organize sub-process of the analyze involves determining how elements fit or function within a structure, recognizing relationships among components and organizing parts into a coherent framework. It emphasizes structural clarity, hierarchical arrangement, and interrelationships between components. Now some sample activities of organize. Analyze components of a power distribution system and organize them into hierarchical structures, generation, transmission, distribution, and consumption, showing the functional interrelations. Okay. Given a set of software modules for a web application, organize them into logical architecture, presentation layer, business logic layer, and data access layer, and describe the flow of control. Given different subsystems of an aircraft, propulsion, avionics, control, structural, organize them into systems architecture diagram to illustrate how they interact to ensure flight performance. Okay, this is organize activity. Then comes the attribute activity. The attribute subprocess of the analyze level in revised Bloom's taxonomy involves identifying underlying bias, assumptions, values, or perspectives embedded in information designs, systems, or arguments. It includes critical judgment of the purpose, credibility, or intention of constituent elements within a context, particularly useful in evaluating designs, decisions, or reports in engineering practice. So, you have to identify underlying bias or assumptions or values. Okay, what are the perspectives embedded in information? Some sample activities of attribute. Review a construction project proposal and attribute the choice of foundation design to local soil assumptions, cost consideration, or risk tolerance rather than purely technical criteria. Can you attribute to your design to what is being maximized or optimized? So that is attribute process. Analyze algorithm selection. in software application and attribute the preference for one algorithm over another to developer bias, system constraints, or assumed user behavior. Now, this particular type of thing is becoming more and more important these days because of the extensive use of AI. Finally, AI is nothing but using certain algorithms. What kind of bias is built into those algorithms? What assumptions have been made by the designer? What did he optimize? For example, it can, in a particular scenario, instead of performing one particular activity in one way, it may result in the opposite type of final performance. So it is taking much more crucial. Like for example, if screening of applicants to a job is done by using AI algorithms, once a complex algorithm is put, nobody has any choice at all on that. They'll just go by the output given by that. But who is going to check what is the bias that is built into that? It may not be apparent, but if one can attribute, but even that ability to attribute the right kind of what do you call biases or values of the designer requires another kind of expertise. It's not very easy. So that is one of the problems related to using AI in anything and everything. Another example, assess a published specification sheet for wireless device and attribute performance claims to idealized lab conditions rather than real world environment factors. Okay, even a published specification sheet itself can be where you can perform this attribute activity. And here finally, you have to really be cautious about using the word analyze in engineering. We have been using the verb analyze in engineering a bit, it's a bit tricky in the sense we have been using left, right, center, analyze as if it's a part of, for example, let me give an example. Analyze a given circuit. What does it mean actually? Analyze a given circuit diagram means you are determining the performance of a circuit. Like you are trying to determine if this is the input, that is the output that comes. To say that, we use the word analyze a circuit. But that is equivalent to actually using the apply process, not analyze process. Not the analyze process as defined by revised Bloom's taxonomy. Sometimes we use the word evaluate a circuit, which is also equivalent to determine some voltage or current in a particular element of a given circuit. So evaluate is also being used in a very loose way. You cannot have three words, right? Calculate or determine, that is belongs to apply, and you have analyze and evaluate. But of course, these people have to use the same words. So it is first you have to be careful, and we have seen this being misused in a very extensive way because of wrong understanding of the word analyze. When we look at the PO2, that is program outcome 2, its wording is problem analysis. Yes, that is what we are doing, and immediately they will say we are doing problem analysis. Actually, none of the activities that are listed there are being done. So, unfortunately, that word problem analysis is used there, which led to a lot of distortion. Okay. Here, and also truly, in a true sense, it is difficult to design any questions in the category of analysis in limited time written examination. You have to give a detailed description of something, and then they have to, all the required information has to be provided within the question paper, and then you ask the student to analyze that information and come to whatever you want him to decide. You have to give him a chance for that. That requires a lot of descriptive information given, and then give a lot of time for him to come to a conclusion. And such questions do not fit into a limited time examination, whether it is 1.5 hours or 3 hours. These analyze activities can only be included in assignments related to case studies, projects, term papers, and field studies. But you cannot, because it doesn't fit in the limited time examination, you cannot push that activity out of assessment, right? You have to give them a chance to experience this analyze. And in the next unit, we will attempt to understand cognitive process, evaluate and create of revised Bloom's taxonomy. Thank you for your attention.